So special angles and why they're special. So we played around with one special angle earlier, 30 degrees or pi over 6 radians. I'm just going to focus on the first quadrant for a moment, and then we'll talk about the other quadrants. I'm just going to draw my best quarter circle. Drawn better. Let's make believe that's a quarter circle. And even better, it is the unit, a unit quarter circle right there. Special angles here are going to be the 30 degree or pi over 6 angle I talked about earlier, 45 degree or pi over 4, and then 60 degrees, about right here, which would be pi over 6. So the special angles here are, earlier we did the pi over 6. Oops. Pi over 4 is this next one. And then this one right here would be pi over 3. And then we know this way up here would be pi over 2. And these are related to 30 degrees, 45 degrees, and 60 degrees, and then 90 degrees. We calculated this point over here as being the point square root of 3 over 2, comma 1/2. Now, if you think about the symmetry in the quarter circle here, pi over 3 happens to be pi over 6 away from the y-axis in this case. So this point up here is just going to be the switch of that point right there. 1/2 square root of 3 over 2. And if you look back at the triangle we made to calculate this point right here, you should be able to see that is true right there. Now this point right here, 45 degrees, that happens to be the line y equals x. So whatever the x value is, the y value has to be also. And I'll calculate that in a minute, but I'm just going to give it right now. That's the square root of 2 over 2. There's one version of that number. Okay, down here, 0 radians or 0 degrees is also important. That gives us the point x equals 1, y equals 0. And at pi over 2, that gives us the point 0 for x and 1 for y. So these are the special angles, and we can reflect these points around to the other 4 quadrants. I'll draw that out in just a second. But I just want to continue a little bit more with these. Now, we know that as the angle changes, both the x value changes, right, and the y value changes with that angle. And those are functional relationships, and they have special names, cosine and sine. So I'm just going to make a little table that matches these special angles here. So my independent variable here is the angle. Okay. So again, what I mean there is I'm starting off here in standard position, positive x-axis, and as the angle moves, the point on the circle, x and y, change with the angle, right? So I have a function going on there. The x value on the unit circle, based on that standard angle, is calculated with a function called the cosine of the angle. And the y value is calculated with what's called the sine of that angle from standard position. And so I'm just going to take this angle information and write down the corresponding x's and y's. So I think the picture is way more meaningful, but we can write it as a table. Special angles are 0, pi over 6, pi over 4, pi over 3, and pi over 2. The cosine starts off at 1 and then shrinks down to 0. So 1 square root of 3 over 2, which is almost 9/10, square root of 2 over 2, which is about 0.8-ish, 1/2 or 0.5, and then 0. And the y value is the opposite. So down here, y is 0. And then as we move the angle in a positive direction counterclockwise, the y value increases 0, 1/2, square root of 2 over 2, square root of 3 over 2. So 0, 1/2, oops, that's a funky square root, square root of 2 over 2, square root of 3 over 2, and then 1. Super important. You should write this down as a picture in a table every other day and have this memorized. It will make the rest of this class much more doable. But if you're always having to whip out the calculator for these special angles, it's going to make this class way harder. So please, please, please draw this out every day until you have it committed to memory. Super important. Now I'm going to extend these special angles. I'm not going to label all of the points, but I'm just going to talk about a few of them. But what does a 30 degree or pi over 6 look like around the circle, pi over 4, pi over 3, and so on? So let's move along. Let's see, do I still have that? Yes. Hopefully it will let me draw on it. So we're going to take a look at our special angles here. So let's start with pi over 4 this time. Pi over 4 is a 45. I meant to use the line tool, but it's not too bad. Pi over 4 is that 45 degree angle. So this is the angle pi over 4, and we can keep going around counting by pi over 4. So here's 1 pi over 4. 2 pi over 4 puts me over here at pi over 2. 3 pi over 4 puts me right over here. 4 pi over 4 would put me over here at pi. 5 pi over 4 puts me over here in quadrant 3. 6 pi over 4 puts me over here. Now 6 pi over 4 reduces to 3 pi over 2. 3 pi over 2's. So think about it. Pi over 2 is 90 degrees, right? So 1 pi over 2, 2 pi over 2, 3 pi over 2 is down there. Ooh, pause for a second. Question. So x is always the cosine, y is always the sine. When we're on circles, that is the truth. Might we mix it up a little bit on a triangle? The answer is yes, and we'll talk about that at the end of this chapter. So as far as circles are concerned, the x value is always the cosine, the y value is always the sine. That can vary in triangles depending on how you look at the triangle, and we'll look at that in the last section of this chapter. So let's see, we're counting by pi over 4. 1, 2, 3, 4, 5, 6, 7 pi over 4 would be over here. Now we counted by pi over 3 earlier. We'll do that one last. So I'm going to do, sorry, pi over 6 earlier. Let's do pi over 3. So I'm going to use red for pi over 3. Pi over 3 lives up here, about. So that angle to get to that point right there would be pi over 3. So that's 1 pi over 3, right? This angle to there. If I keep going by that angle, that's going to put me over here. This would be 2 pi over 3 here to get to that point. And then 3 pi over 3 puts me over here at pi. Another pi over 3 puts me over here. So that would be 1, 2, 3, 4 pi over 3 to that point. Pi over 3 further is going to take me over to here. So again, what am I talking about the pi over 3? It's the angle that sweeps this part of the arc, right? So that's 1 pi over 3. And then 2 pi over 3 to there. 3 pi over 3 to there. 4 pi over 3 puts me here. 5 pi over 3 puts me over here, right? So I'm sweeping that angle, and the angle and the arc are the same on the unit circle. We went over that last week. So this right here is 5 pi over 3. And if I do one more sweep of pi over 3, that takes me to 6 pi over 3. And 3 goes into 6 twice, which is 2 pi, which is 1 revolution, or 360 degrees. So I think I did a good job getting that to happen there. Right, so special angles related. So these, again, the basic special angles are these right here. 0, pi over 6, pi over 4, pi over 3, pi over 2. But we have 3 other quadrants, so I can extend those going around. So these are more of those special angles coming around here. All right, so we did the pi over 3 versions. We also squeaked in some pi over 2's because 2 pi over 4 is pi over 2. So that was a natural consequence there. We did the pi over 3 versions coming around. Let's go back and look at pi over 6. Did that in blue. Pi over 6 lives about here. So the angle to get to that point right there is pi over 6. And so let's go around counting by pi over 6. So 1 pi over 6 is the arc or angle on the unit circle that takes me to there. 2 pi over 6's puts me here. I already got that one. That's pi over 3. 3 pi over 6's takes me here. 3 pi over 6 is pi over 2, half of pi. So that's 3. 4 pi over 6, I already got it. Over here, that would be 5 pi over 6. I don't have that one yet. So that would be 5 pi over 6. 6 pi over 6's, well, that's pi, I got it. 7 pi over 6's takes me right here. 8 pi over 6's, got that. That's the same as 4 pi over 3. 9 pi over 6's, let's just double check. 9 pi over 6, 3 goes in the top and bottom, reducing down to 3 pi over 2. Check, got it. That's that angle. So that was 9 pi over 6, 10 pi over 6, 5 pi over 3. 11 pi over 6, I don't have that one yet. Okay, and let's see, how did I do? I didn't, oh yeah, I did label this one. That's 0 radians or pi over 2 radians. So I have all the special angles coming around. So at each quarter, right, we have a version of pi over 2, pi, 3 pi over 2, 2 pi. And then there are 3 special angles contained within each quadrant. And they are all related to pi over 6, pi over 4, or pi over 3. So for example, earlier I claimed, without any proof, we'll prove it eventually, that the points on the unit circle when the angle is pi over 4 radians is the square root of 2 over 2, comma, square root of 2 over 2. Meaning that the x value is the cosine of that angle, pi over 4, has to be the square root of 2 over 2. And the y value from that point is the sine of the angle. The angle was pi over 4 radians. That's also the square root of 2 over 2. That's quadrant 1, right? If I were to jump into quadrant 3 over here, I know that x is negative and y is negative. Oops. Negative, comma, negative. So then this point, all I have to do is make them negative. So at 5 pi over 4, that has to be the point negative square root of 2 over 2, negative square root of 2 over 2, which tells me that the cosine of 5 pi over 4 has to equal negative square root of 2 over 2. Okay, what's the point of all of this madness here? The point is, if you memorize this quadrant right here and the related sines and cosines to their special angles, then you know the whole unit circle special angle. You know all of those things just because you know what sine x and y has to be in each quadrant. And that pi over 4 has relatives living all over the place. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And I mentioned earlier in the class, I'm going to mention this every day, drawing pictures helps you do trig. So if you're trying to do all your homework without drawing pictures, you're making it way harder on yourself. Draw pictures, draw pictures, draw pictures. All right. So next thing I'm going to do, I don't need to name all of these points. We know the points in the first quadrant. We could then, if I asked you to name the values of every one of these points, x and y, based on the angle, and there'll be homework problems like that. So you get to practice that. Let's take a look at y, the sine of pi over 4 is square root of 2 over 2, and then we'll look at some homework questions.